The value of a painting after t years will be right here, is given by p. All right, so part A, very easy. To find the value of the painting after 3 years, we just sub t equals to 3. So we write out the function here and put t equals to 3 right here. And so after correcting it to nearest integer, the answer will be $45326, and that'd be the answer. Now, part B, we want to find the increase in the value of the painting in the 4th year. Why is it increased? Because it's exponential and this base is greater than 1. So it keeps going upward, right? But for the increase in the 4th year, think about it. To calculate the increase in the 1st year, we would just find when t equals to 1 compared with the value at t equals to 0, right? And we subtract it. So for the 2nd year, it would be p of 2 minus p of 1. And so the 4th year will be p of 4 minus p of 3. We always get this confused and mixed up the t value. Maybe it's p of 5 minus p of 4. We don't know. So in this way, listing it all out like that will help. So for part B, p of 4 minus p of 3 equals to this by using the formula and by substituting. This could be easily done by factorizing, right? And so the increase in the value would be $4,079. Now here's the hardest part, part C. How many years later will the value of the painting first exceed $150,000? Now the value, p of t, right, the function, so we set it greater than 150,000. So we write out the entire function here, and then we move the 35,000 to the other side and simplify it. Then when we log both sides, the t will come down. In another video, we've talked about the inequality not being affected by logging on both sides. We're not going to talk about the details on this, but remember, logging both sides does not change the direction of this inequality. Then I move this number to here, right? Now, if I'm moving a negative number, this one will have to change. But log of 1.09 is actually a positive number. So if you remember the graph of the log, and you need to recognize that only when x is between 0 and 1 will this part be negative. Your y would be negative. And greater than 1 here will just always give you a positive number. And just a reminder, the domain here, the x will never be less than 0 or equal to 0. And so using calculator, t is greater than 16.9, and so the value of the painting will be more than $150,000 at least 17 years later. Now, one of the most used application of logarithm would be sound intensity level. This is given by this formula here, and L would be the actual sound intensity level that we want to calculate, and it's equal to 10 times log of one number over a fixed constant. This I would be the sound intensity that we want, and I naught is a fixed constant, and the unit would be watt per meter square. And it's actually the lowest sound intensity that human can hear. And so this is also with the same unit for sound intensity, and it's actually a quotient. It's all relative. And after calculation, you get this level, sound intensity level, and the unit would be decibels. Now we can jump right into the question. The sound intensity level of the noise generated by a vehicle. If that's a level, then it would be the L, right? Goes from 78 decibels to 81. And we want to find the percentage change in sound intensity of the noise. That is, we have two I's respectively, and then we want to find the percentage change. So we start out by letting the unknowns assume that the sound intensity of the noise goes from I1, which corresponds to this L, to I2, which corresponds to this L. When we have I1 for the intensity, the corresponding intensity level would be 78. And when the intensity is I2, the intensity level would be 81. And so we have two equations, two unknowns. And so we got I1 for this and I2 for this. Now we can find the percentage change. And it would be new minus old divided by old. And the answer would be an increase of 99.5%. Another very important use of log application would be the magnitude of an earthquake. This scale is what we call the Richter scale, given by this formula. And m would be the magnitude. These numbers can be decimals, which equals to 2/3 times the log of E minus K, where E is the energy release in that earthquake, and K is a positive constant, and we may not know what it is, and it depends on the situation, okay? So this question, there are two earthquakes. The first one with a magnitude of 5.4, somewhere around here, and the second one was 4, this one. How many times was the energy released in the earthquake as much as that of the subsequent earthquakes? Okay, so obviously the first one would have more energy, and we want to know how many times it is compared to the second one. So we first let E1 units to be the energy associated with the first earthquake with m equals to 5.4, and E2 be the subsequent one for the energy associated with the one with magnitude of 4. So obviously we can write into these two equations, but you can notice that there are actually 3 unknowns with only 2 equations. But that's okay. We don't need to find the exact number for E1 and E2. All we need to do is just to find how many times. So in other words, we just want to find E1 over E2. Take equation 1 minus equation 2. This I get 1.4, and these two will cancel out. Then we could combine these two together. Then we could get 126. And so in terms of energy, the first one would be around 126 times of the second one.